If you zoom out far enough, the universe looks like a glowing web. We've mapped it as a series of dense galaxy clusters and brilliant filaments, a structure we expect to behave predictably. Cosmologists rely on this math to figure out how fast the universe is expanding. To verify the math, they use two completely independent measuring tools. This map shows the ancient radiation pattern left over from the very early universe. By looking at temperature fluctuations in the cosmic microwave background, physicists calculate the initial expansion rate. Extrapolating forward to today yields a speed of 67 kilometers per second per megaparsec. The second tool focuses on our immediate neighborhood. Scientists measure the pulse rate and brightness of local stars and supernovas to determine distances. This local ruler consistently calculates the expansion rate at 73 kilometers per second. These two reliable rulers point to two different versions of reality. That 6% gap contradicts our foundational understanding of cosmic physics. This discrepancy shorthands a massive chronological problem. A higher expansion rate makes the universe younger. If correct, the universe is younger than its oldest stars, an impossibility. Both measurements have been double-checked. The probability of a random error is 1 in millions. Cosmologists call this contradiction the Hubble Tension. The Standard Model of Physics, which explains the rest of the observable universe, has hit a wall. Since the math and the tools are working, the flaw may reside in the physical location from which we are taking the measurements. To understand how our location affects our data, we have to look past our local galaxy and zoom out to an extreme macro scale. The Milky Way sits inside a massive, underpopulated region of space. We are drifting inside the KBC Void, a local underdensity roughly 2 billion light-years across. It is an immense cosmic hole where matter is unusually sparse. Inside a structure like this, gravity creates a lopsided tug-of-war. The center of the bubble is virtually empty, exerting almost no gravitational pull on its contents. The dense outer edges are packed with galaxy clusters and dark matter. These heavy walls possess overwhelming mass, creating a steep gravitational gradient. The Milky Way and our neighboring galaxies are being physically pulled away from the empty center and dragged toward those heavier outer walls. Our entire cosmic neighborhood is caught in a local flow, drifting at hundreds of kilometers per second toward the denser shores of the universe. When our telescopes measure neighboring galaxies, they record the speed at which those galaxies are moving away from us. Part of that recorded speed is our own local physical movement within the void. This drift mimics the appearance of global universal expansion, inflating our local calculations. In a typical, heavily populated region of space, the gravity of clustered galaxies pulls inward on everything, acting as a natural brake that slows local expansion. Our void lacks that dense matter. Without the gravitational braking system, the empty space around us stretches out faster than the cosmic average. The Hubble tension exists because our local ruler is corrupted by the physical illusions created by living inside a cosmic hole. The KBC Void hides the truth from us right now, but it is a temporary blind spot compared to the permanent erasure of information coming for the rest of the universe. This timeline shows how the expansion of space is accelerating. Eventually, the physical distance between us and the furthest galaxies will stretch so rapidly that their recession speed will exceed the speed of light. Once those galaxies cross our cosmological horizon, their light will never be able to physically reach us again. That same stretching effect will target the cosmic microwave background. The residual heat from the Big Bang will cool and stretch until it becomes an undetectable radio hum. Over hundreds of billions of years, the physical mechanics of the cosmos will erase the historical evidence of its own birth. Imagine a new civilization evolving in the distant future, long after the Milky Way and its neighbors have merged into one isolated supergalaxy. Future scientists will point perfect telescopes into the sky and see a void. No distant galaxies, no measurable expansion, and no ancient light. Their precise math and flawless observations will prove that their lonely galaxy is the entire universe, and that it has always been unchanging. They will be completely wrong. The universe never reveals itself in full. Our understanding of reality is a temporary illusion, dictated by the exact sliver of space and time we happen to inhabit.